Today, we're going to be working on your domain and range of inverse functions and why they end up the way that they do. So let's first go ahead and graph y equals the square root of x plus 2 and find your domain and range. So I'm using Desmos here, and you'll notice that I have everything lined up. So I just get to click and go. So when I go ahead and graph it, I should have a function that looks like this. And we get to read your function from left to right if we're talking about domain and bottom to top when we're talking about range. So there's a crucial point here at -2, 0. And if I were to plot a few more points, we have -1 and 1. And I'll do one more. We have 2 and 2, right? Taking a look at your domain, we read from smallest to largest, so left to right. Your leftmost point is at -2. And if we're looking at your x values, it looks like they're getting larger and larger as your function grows up. So we go from -2 to infinity. We are going to use a bracket around -2 because there is a point at -2. We can even go ahead and plug -2 in. We get the square root of 0, which is 0, and that is a good number. Now, when we talk about your range, we're reading from bottom to top, or your smallest to largest. So looking at your smallest y values, we have here at 0. Then as we look upwards, your y value is going to continue to grow as you go out. So we're going to go from 0 all the way to infinity. So this is the domain and range of your original function. Now let's go ahead and find your inverse. So it says y is equal to x squared, or sorry, the square root of x plus 2. Now, if you don't know how to find your inverse, please go back to 4.4 or some of those support worksheets to figure out how we get your inverse. So the first thing we were going to do is swap your x and y. Now, in doing so, when we swapped your x and y, we are swapping your domain and range. So we swap your domain and range. And in doing so, when we go to solve your function, we have the square root that's in a way. So we are going to square both sides. And we're going to be left with x squared is equal to y plus 2. And we're going to go ahead and subtract 2. So your inverse function here is x squared minus 2. So let's go ahead and graph that on your graphing calculator or your Desmos. So I graphed it right here with my red line. We had y is equal to x squared minus 2. So when I look at this graph, this graph is wrong. So let me just go ahead and quickly grab that correct looking graph. So when we're looking at your domain and range of this new graph, it should, if we've done it correctly, line up with what we truly have. So as I'm importing in my nice new graph right here, it's a little large for me. Wanted to replace that whole graph right there. There we go. So now, again, reading your domain and range from this particular graph, right? Your smallest x value we have, if I'm going to plot a couple points, we have -2, 2. We have -1, -1. We have -2, 0. And again, I'll plot just a couple more. 1, -1, 2, 2, and so forth, right? So when we look at your x values, right, they're starting out negative, and we can plot some more if we want, but they're starting out negative, meaning that they're coming from negative infinity. And as we approach your center, we go to -2, but then I'm so sorry, I swapped those two. We go from 0 to -2. And as we look at your x values, they're going to continue to grow. So we have your domain here, all real numbers. And for your range, we go from your smallest y value, which in our case is -2. And on either side, we can see that your y values are continuing to grow. So we have -2 to infinity. But we said your domain and range should be swapped. What I mean by that is your domain here should be your range, which when we look at it, this looks really, really good. That one fits with that idea. However, look at your range. Your range on this one goes from 0 to infinity. And when we swapped it, it now becomes your domain. But that doesn't line up. So what happened? Well, what happened is that this actually isn't the correct inverse because your inverses, right? The your inverses are actually mirrored over the x is or y is equal to x equation, and you'll see that down here. So if we were to adjust your domain here to then represent your range from the first graph, we should actually only have half of your graph. And when we compare that to the original, right, notice that there should be an overlap. We are actually taking the inverse, and in doing so, we reflect it not over the y, not over the origin, and not over the x axis, but instead we're reflecting it over this x is or y is equal to x equation. And they should be mirrored each other. So it happens on one side, should happen on the other side, is that you're seeing right here, right? So the point here, -2, 0, is now appearing right here, 0, -2. You have swapped your x and your y. And that goes for all of your points. We've switched your x's and y's, and that switching, right, appears in your domain and range. So your domain and range are now flip-flopped. So this graph in purple is the accurate graph for your inverse function. This has the function, your inverse function, I should state, as x squared minus 2, as long as x is greater than or equal to 0. That greater than or equal to 0 represents this point here. So from 0 to infinity. And that's how you would write it in, like if you're doing Desmos, but your domain here is from 0 to infinity, and your range on the other side is from -2 to infinity. Again, this point being up for debate, so 0, -2. And if you plot random points, we have 1, -1, we have 2, -2, right? And we can see that these x values, right, they start at 0 and they're going to get larger. Start at 0 and get larger. And your y values start at -2 and they will get larger as well. So keep in mind your domain and range every time you swap your x's and y's. You don't need to reevaluate your graph if you have originally done it in the first place.